Is time travel possible? Exploring the science behind it. Time travel, one of the most captivating concepts in science fiction. From H.G. Wells' The Time Machine to blockbuster movies like Back to the Future, the idea of journeying through time has fascinated humanity for generations. But what if I told you that time travel might not just be a work of fiction? Could it be possible in the real world? Let's dive into the science behind it. Hey everyone, welcome back to the channel, What If Explorers. Today we're tackling one of the biggest questions in physics. Is time travel possible? We'll explore what modern science says about this, discuss theories, and see if we can separate the science from the science fiction. The basics of time and space. First, let's break down the concept of time. According to Einstein's theory of relativity, time and space are intertwined in what we call the space-time continuum. Imagine it as a fabric. Objects like planets and stars create dents in this fabric, and the more massive the object, the bigger the dent. Now, this theory also tells us that the closer you are to a massive object, the slower time moves relative to someone further away. This phenomenon is called time dilation, and it's been proven with precise atomic clocks placed at different altitudes on Earth. Time dilation and real-world examples. Time dilation isn't just theoretical. Astronauts aboard the International Space Station experience time slightly slower than we do on Earth. After spending months in space, they've actually aged a tiny bit less than if they had stayed on Earth. But this effect is minuscule, far from what we imagine in time travel movies. We do have experimental proof of future time travel. The concept of future time travel is based on the phenomenon of time dilation, predicted by Einstein's theory of relativity, and it has been observed in several experiments. But what about moving forward or backward in time? Here's where things get interesting. Theoretical physics suggests that wormholes, shortcuts through space-time, could allow us to travel between 2 points in time, just like traveling through space. But there's a catch. Wormholes are purely hypothetical, and even if they do exist, they might be incredibly unstable. And then there's the concept of faster-than-light travel. If we could somehow surpass the speed of light, time as we know it would start to behave very differently. But according to Einstein's equations, nothing with mass can reach or exceed the speed of light. It would require infinite energy. So for now, faster-than-light time travel remains in the realm of fiction. Time travel to the future is theoretically possible, and it's actually something we can observe on a very small scale through the concept of time dilation, which I mentioned earlier. If you travel at speeds close to the speed of light or experience strong gravitational fields, time will slow down for you compared to someone in a weaker gravitational field or at rest. This means you would age more slowly and effectively travel into the future relative to someone who stayed behind. However, traveling to the past is a much more complex and speculative idea. Traveling to the past presents several significant challenges due to the fundamental nature of our physical laws and the paradoxes that arise. Current physics, particularly Einstein's theory of relativity, doesn't allow for straightforward backward time travel. Here's why it's so difficult. Causality and the arrow of time. Causality. One of the core principles of our universe is causality, which means that cause precedes effect. If you could travel back in time, you could potentially alter events that have already occurred, creating contradictions known as causal paradoxes. Arrow of time. Time has a directional flow from past to future, often called the arrow of time. This is tied to the second law of thermodynamics, which states that entropy, disorder in a closed system, tends to increase over time. This law implies that time naturally moves forward, making backward travel against the natural flow. Infinite energy. According to relativity, traveling faster than light would theoretically allow you to move backward in time. However, to reach or exceed the speed of light, an object with mass would require infinite energy, which is not possible according to our current understanding of physics. Uncertainty and quantum effects. At the quantum level, particles exhibit behaviors that seem to defy classical logic, such as being in multiple places at once, superposition, or instantaneously affecting each other at a distance, entanglement. Some interpretations of quantum mechanics suggest the possibility of alternate timelines or parallel universes, but this is still speculative and doesn't provide a practical mechanism for traveling to the past. While some theories propose the possibility of wormholes or other exotic phenomena that could theoretically connect different points in time, these ideas are highly theoretical and come with many challenges, such as stability issues and paradoxes like the grandfather paradox. The grandfather paradox and time travel in popular culture. Let's not forget about the paradoxes. One of the most famous is the grandfather paradox. What happens if you travel back in time and prevent your grandfather from meeting your grandmother? Would you cease to exist? These paradoxes create massive headaches for physicists and suggest that time travel into the past might be impossible or lead to alternate realities. So, the future of time travel. So is time travel possible? The short answer is maybe, but not in the way we imagine it. While time dilation is a real and proven phenomenon, traveling through time as we see in movies is still a dream. Advances in theoretical physics might one day unlock new possibilities, but for now, we'll have to keep our time machines in the realm of science fiction. What do you think? Will we ever crack the code to time travel? Drop your thoughts in the comments below. And don't forget to like and subscribe for more mind-bending explorations of science and technology. Until next time, keep wondering. This script blends scientific concepts with engaging visuals and narrative, making the complex topic of time travel accessible and interesting for viewers.